Welcome and good evening to this webinar. So before we begin with the session for today, let me briefly introduce myself, everyone. I'm Rishikesh, your webinar host for the day. I have over 15 years of experience of working in the IT industry now, and I've worked with various global teams in designing big data solutions using technologies like Hadoop, Spark, and many cloud native technologies, almost with all the cloud vendors. In today's webinar, we are going to talk about two different technologies basically. First of all, big data and then AWS. And then we are going to see how we can combine these technologies to process your big data, store your big data and analyze your big data. So let's have a look at the agenda. So we will begin with what is big data, and then we will understand what is AWS. Many of you might be aware of what is AWS and cloud computing. And then we will see what are the different aspects of big data in AWS and how AWS can solve the kind of big data problem that we have. Instead of calling it a problem, let's call it as an opportunity. So we will begin with what big data actually is. So as you can see on the screen here, big data, the dictionary definition of big data is the collection of data sets that are so large and complex that it becomes difficult to process using on-hand database systems. We call them as legacy RDBMS systems and tools or traditional data processing applications to even process this. Forget about processing, but then even the storage of these things become really very difficult. You can also consider big data as a high volume, high velocity, high variety information assets that demand cost-effective, innovative forms of information processing that enable enhanced insight. Now, all of this big data is nothing but the raw data, right? But it has tremendous value hidden in it in the form of insight patterns, which can help you take top decisions, which help businesses take informed decisions, and also can do very sophisticated process automation, right? So we are going to look at these different aspects of any data that makes it a big data. Now, what is this data all about? What is this entire fuss all about? Let's have a look. Now, is this data coming from somewhere else? Is this a different category of data that we are calling as a big data? The answer to this is no. Big data is the same data that we have been using processing in the past, using artificial RDBMS and other means of storing and processing data. But there are characteristics which are attached to this data, which is making it as data. These characteristics are because of there are certain properties which are attached to this data because of the way we produce and use this data. What are these properties? There are 5 properties of any data that can categorize this data as big data. We call it as 5 B's of big data. Volume definitely is one of the important property of any data that makes it as a big data. The sheer size of the data is big data. So when we are talking about a data volume, which is in terms of terabytes and petabytes and zettabytes, is actually big data. So I've given a small out here, which will show you the kind of exponential growth that we've been seeing in the last couple of days from 2020. We are the first quarter of 2022. And we've seen that whatever had been predicted by IDC, International Corporation, for the year 2022, we have gone much ahead of that. The pandemic and the kind of generated the pandemic vaccination, all those things. So this is much more than what was predicted for the year 2022. For the 2020. In the year 2022, first quarter, we are already seeing an exponential growth in that. So the point here is, as we move on further, the volume of the data is going to be huge. Correct? And the RDBMS systems and the databases and Oracle and everything is no match. They cannot even stand in front of this because they cannot store the data as an entire population. Okay, they can store some sample maybe, and the rest of the data archive. That is not what process. You can store the data, and you cannot work out. You can analyze it as one full data, right? So volume definitely makes data as a big data. The second is variety. As volume itself wasn't enough to make it more complex, now big data also has one character, that is variety. This huge volume of data is not in structured format. Okay, so let's say somehow RDBMS managed to put data, but then the sheer nature of unstructuredness that we have, the varieties of data that we have, this is not stored. There is not able to store all that different varieties of data. So when I say variety, I'm talking about structured data that we have now, which fit in the tables, those important second structure. But the nature of the data that we have today is in the form of structure. We have various file formats ranging from JSON, XML, CSV, email bodies that we need to analyze these days. That is your semi-structured data. But then most prominently, the data that we have is of unstructured type. Now, what is type? It doesn't have structure to it. You cannot store data within that kind of file in the form of rows and columns. It's completely unstructured data. So your images, your log files, your audio, videos, you will only upload on social sites like Twitter, Facebook, Instagram, and those kind of things. Now, for us, it can be a fun element, right? For some of us. But then many corporations are using this data in minds of companies like Facebook, Google, right? So variety of any data definitely needs big data. Thirdly, that is responsible for getting this data into the big data category is the velocity. All this huge volume of data, this variety of data is getting generated at tremendous speed. What do I mean by that? Everybody has handheld devices nowadays, mobile phones. We are accessing various e-commerce applications, social networking applications. We are generating data, we are checking emails through them. Not only that, but then the IoT devices, different satellite devices, cameras that capture information every second of the day. And this is happening all over the globe. And the big servers are capturing this data. This data is moving to the servers online. tremendous velocity, correct? And the solution that we have need to be strong enough or need to be able to, accommodate this data at this tremendous speed. So definitely, the velocity at which the data is generated is making it as a big data. These three are the problems, are challenges that we have. When we all these challenges, we know that the data that we have here has a tremendous value. It's a gold mine. If we store it and process it efficiently in time, then it has a wealth of information in it, and that information can be used to build futures, fortunes for many companies. And that's happening nowadays. We see these networking giants are growing so large, it's based on value that they have provided. So this value, having said that, getting this value is not easy. We need to have proper tools. We need tools which will enable you to do that. The fifth property is the velocity of the data. Not even the velocity. Velocity means the inconsistencies, the junk, the noise, the uncertainty in your data. We don't have to get from resources. It can be from a kiosk, it can be from satellite, it can be from an IoT device, cameras, which locations, which sources coming from. Each source might capture it in a different format. And then might be a certain noise, certain uncertainties, inconsistencies in the data. That means null values, some values, star values, output values, outliers, and things like that. Now, if you ask any data scientist, you will understand that most of the time, almost 70 to 80% of their time is spent on data cleansing or wrangling or data flattening, as well, data smoothing. So they have to work on this data, have to put some time and effort, put technologies for tools to cleanse this data, get rid of all these things, basically velocity in the data. So velocity is definitely one of the challenges, one of the properties that make this data as big data. What do you mean by value? Value means the kind of information that is hidden in this data. Okay? The value is not a challenge, right? It's what we get out of this data. But then getting this value, how do I get it? The kind of tools that I buy, the proper set of tools we deploy to analyze this value. The value itself becomes the property of the data. When the data has tremendous value in it, we call it as a big data. Okay? So data is just not one property, it's a combination of different properties, such as volume, variety, velocity, value, veracity, that makes this data as a big data. Is that clear? Okay, so let's move on to the next one here. After having understood what data is, now let's try and understand what AWS is. AWS is Amazon Web Services. It is a secure cloud service platform. All customers use Amazon, like for retail shopping, those kind of things. So Amazon Web Service is one of its subsidiary. On Amazon, you get books, you get other items, maybe you can with that, you have been shopping there. But AWS is actually a subsidiary which deals in servers, storage capacities, network, and those kind of things. This is also a market, but when you rent resources, we don't buy resources, we rent resources from Amazon. And that subsidiary is called as Amazon Web Service. But the many services that AWS provides, that is compute. That means they give you virtualized servers on rent. So you, instead of buying servers in your data center, maintaining them in your data center, you go and rent a virtualized server, which is called an EC2 machine from AWS. Instead of having your databases in your data centers, you will go and have your S3 bucket, that is storage, data delivery, and many other kind of services provided by Amazon services. So in today's webinar, we will see what kind of services are available from AWS, which allows us to have big data in AWS. Okay. So there are many services in AWS that allows us to do cost-effective and efficient processing for big data in the AWS infrastructure. When I say AWS infrastructure, all your servers, all your wiring, all your networking, everything is in somebody else's data center. Okay, we are using the virtualized version of those resources which are maintained by AWS. Scientists, developers, and other technologies from many different domains are taking advantage of this infrastructure of AWS to perform data analytics and meet critical challenges of ever-evolving data. Data is huge, right? Data is huge. So if you are going to set up your own infrastructure in your own data center, then there is going to be a huge requirement of hardware, servers, and all of those things. And what if you can, instead of buying it, what if you could rent it from someone? AWS is flexibility. AWS is not only for cost, but it is for flexibility. Tomorrow, if I want to do something, or if I want to then I can simply stop AWS services. All that hardware is not with me anymore. So I don't have to buy it and I think about it once I'm done with it. Just rent it, pay AWS for what you use. Right? AWS offers you a portfolio of cloud computing services to manage big data by significantly reducing the cost that I just spoke about. Right? The cost is less, so buying or renting yourself. It also allows you to scale in, scale out. Right? In certain periods of the year, you might have more traffic on your service, on your web page. Then you just go and bring this service. And the season is over. Just so scale out can be done. Also, you can have any speed of your processing by having more and more stronger machines. You can upgrade, right? Scale up, scale down. So Amazon Service provides a fully integrated portfolio of cloud computing services. It has huge number of services, not only storage and processing, but then many others. So furthermore, it helps you build, secure, and deploy your big data applications. Security is also taken care of by AWS. Right? Also, with AWS, you don't need hardware to procure and infrastructure to maintain scale. You need to set up your own data center. Correct? With this, you can focus on resources, on uncovering new insights. So you don't have to focus on setting up the environment. You don't have to focus on setting up the servers, storage mechanism, networking, and maintaining the stuff, maintaining that, doing infrastructure for you don't have to do that. You can focus on your business and let AWS take care of all the underlying infrastructure. You can focus on finding insights from the data. Right? So since new features are added constantly, you'll always be able to leverage the latest technology without requiring to make long-term investments. Not only you're getting the existing technologies at a very flexible rate, but then whenever something new comes up, AWS always upgrades its infrastructure with those new things, and all those become available to you to explore, right? And that without having any upfront investments. Quick emphasis, this one, right? So this is the new era of cloud computing, and you can definitely benefit from that. And we are posting on top of AWS. So now let's see how AWS can solve big data challenges for you. Okay? Now, any big data related project has these 4 phases. We understand what these 4 phases are, and the platform provides you tools and applications to cater to these. Now, somebody was asking me to do that processing and writing. Though many designers have their in-house built tools, that's about software. And here, it also has certain tools which are native to the cloud, which are provided by AWS. So we will talk about those tools in each of these 4 categories. So when you're saying processing, whether it's in-premise or on cloud, we have these 4 stages. Let's look at each of this now. If you understand what each of these stages are, then I will take you to different tools which are catering to these. So AWS has numerous solutions for all development and deployment purposes related to data. Also in the field of data science and big data, AWS has come up with recent developments in different aspects of big data. Before jumping to this, you first understand these aspects of big data and what AWS can provide. What solutions can AWS provide in each of these aspects? So there are, as you can see on the screen, there are four aspects of any big data processing. The first one is data ingestion. We will talk about each of this separately. The data storage, then data processing, and finally the visualization. So let's talk about what each one of this is. When you say data ingestion, it is collecting the raw data from transactions, from logs, from mobile devices, and many more. So what are the sources of big data we spoke about just a while ago? Data ingestion is also collecting data from all of these services, no matter what speed or volume that they are made for understanding that volume and that kind of speed. Right? It is the first challenge many organizations face when dealing with the big data. Okay? If you're doing it in internet, then you'll have to find out what tools are available in the market and keep constantly upgrading yourself. Now, a good big data platform makes these steps easier. Correct? Any cloud platform is your data will make it easier, especially AWS. How do that? By allowing developers to ingest a wide variety of data from structured to unstructured at any speed using real-time or batch mode. This data is going to come at very volume, huge speed. Not only that, it can be in structured format, it can be in unstructured format, any type of data. It can be streaming data, it can be batch mode data. So my tool that I choose for this data ingestion should be capable of understanding all these different kinds of data, varieties of data. Right? The second phase is your data storage. Any big data platform needs a secure, scalable, and durable repository to store data prior to even processing. Processing comes first. Once you have got data from the sources, now the big challenge is to stage that data. When you stage that data, not only stage that data, but once you have it in stage or in systems, you need to secure that data, right? And this is a big data we're talking about. So big data would never have a maximum limit. You can never say to the system, okay, this is the limit of which I can accommodate data. The very nature of big data is increasing volume. So your systems wherein you are storing this data needs to be scalable, means to be able to expand whenever I like. Scalable, not only secure, not only scalable, it also needs to be durable. The data should always be guaranteed from the system whenever you want it. Right? So these are the 3 important aspects: scalability, security, and durability or availability. Right? The security is not just data in setting data or the stationary data. Then the data is also in the transit. It is moving from system to other. It should be encrypted. So that is the second aspect of data processing. Now, once the data is ingested and stored securely, now you need to process it. Processing is the most important aspect. I spoke about data cleansing, density, and all those things. That is part of processing. It's a step where data comes from its raw stage into a format. Like the data is it has various inconsistencies. It has huge amount of velocity. Any scientist or any data analyst or any big analyst will spend the most of his or her time on running that data, cleansing that data. It needs to be converted to some format which can be further processed. Usually by means of sorting, aggregating, joining. They will perform more advanced functions than algorithms. They might use available or you might find levels of tools in the data processing. There might be certain algorithms developed by the data engineers or machine learning engineers or whoever is working on that data. Doesn't get available storage for further processing or made available for consumption by business intelligence and visualization tools. So you get data from the sources, store it securely, start processing, start cleansing it, start processing it, apply algorithms and that. From the user's algorithm, you analyze this data, find some kind of pattern, some kind of information from it now. Right? This information is in the form of numbers. Correct? The business doesn't understand numbers. What business understands is a story. You should be able to, after all this processing, after all these numbers, you have that number in your hand and have the information in your hand. Now, final stage is visualization. You need to tell the business the story of what data is telling you of business. So based on the past data, the data, what steps you take to make success. Right? So big data is all about getting high value, actionable insights from your data assets. Ideally, data available to stakeholders who set service business intelligence and HRD tools. So when you process the data, you get in, you create various graphs, various dashboards, so that you make it simpler for business to understand the valuable information to derive from this. So visualization is the last and the most important aspect of data processing. From all that huge chunk of data, not a huge raw pile of data, you have flattened it, you have cleansed it, you have stored it, you have analyzed it, and you have found the gold out of it. Now you need to present that gold to business. Right? So the cloud platform, any cloud platform, especially AWS cloud platform that you use, should have tools in each of these categories which will make your processing of data easy for you. Okay? It might be possible that one cloud platform might not have all of these tools, and that's why the concept of multi-cloud processing is also when you have some tools for your data processing on AWS, some of the tools like you go as your 𝐺CP, and then your entire data processing or analytical system is made of multi-cloud. And then we talk about all the tools which can be all the aspects, 4 aspects of data processing on the AWS cloud side. Okay? So let's now get into the AWS tools available to us in each. So the first one is your data ingestion. Let's see what tools are data ingestion. The first that we have in this category is Census. But as AWS Census for how to it is a free managed service. What do you mean by managed service? That means as a customer, you don't have to worry about the aspect of the tool. Upgrading, maintaining, everything is done by AWS. The only thing that is owned by the customer is the data. But everything else, is all done by is all managed by AWS. So it's a managed service for real-time streaming data directly runs on S3. So Census is generally used for streaming, getting the streaming data integrated. Mostly data storing and then you talk about streaming storage. Census firewalls automatically scales to match the volume and throughput of streaming data and requires no ongoing. So Census is used for getting your streaming data. As and when the data is produced in that data, you will use Census. Normally, Census is only streaming data in it, but then as and when there is a source and search in that volume data stream, Census is made in such a way that it automatically scales up that one. Right? You can configure a Census to transform streaming data before you store it in Amazon S3. So mainly Census is for connecting to sources of streaming data. Because Census is only for streaming data, right? And then it is storing data just as S3. The next one that we have here is category is Snowball. So if you look at the picture here on the screen, it looks like a briefcase. And it's a briefcase, very powerful briefcase. We use Snowball to securely and efficiently migrate bulk data from on-premise storage platforms and to S3 buckets. As you can see the diagram here, it looks like a briefcase, and this briefcase can hold size of saved data. Now, if you use it, streaming data, so then there are scenarios when you have huge amount of data in your local data centers or your local systems, and now you want to get into S3. You want to download and you have some bandwidth and it might be exposed to the internet. It will take that much amount of data. So in one go, as a batch, you load all this data from your local data centers into AWS-based storage systems such as S3. So what you need to do is you need to create a job. After you create a job in this management console, you automatically get Snowball clients. So this is actually a hardware appliance which is delivered to you by AWS. And then after Snowball arrives, connect your local network, install the Snowball client on your data center, and then use the Snowball client to select and transfer the file directly to the Snowball device. All your data is not used in this. Basically, just device to the AWS Exam and over there. So these are the lines for the single data and one for the batch data. Now we are talking about Snowball. Only the data is huge. Okay, it's not just you don't have this. So that's about the data ingestion. The next aspect of your data. So data is ingested in system. The next responsibility is to get stored. Database storage. Also, you can see we have these two tools we probably use. That is Amazon S3 and Amazon Glue. Let's look at what these tools, what are these tools provide you. Amazon S3 is secure and highly scalable durable object storage with millisecond latency for data access. Like you also use Google Drive and Dropbox and those kind of applications. So Amazon S3 is your Amazon cloud-based storage solution. It's an object storage. So it doesn't really care about what kind of object it can be. It can be video, audio, it can just on any format. You can just dump it. Right? It has various tiers depending on what you like. You can have different tiers of S3 storage, and then as for the storage tier that you selected, you have to pay more less money. But then you don't have your storage as storage infrastructure because just limiting that space in Amazon S3. S3 can store any type of data from anywhere. Websites, mobile apps, or applications, and data from any sensors in any format can be storage or can store them. It can also store any amount of data with unmatched availability. Now, what's so important? Now, some of the many banks, these kind of corporations were concerned because they used to have their data in their own devices and their own data sets, but then they have control over it. They were concerned about the latency, the availability, the security. So let me tell you, AWS has more certifications and more security than any corporation can even think of because that's their business. The kind of certifications as well as the security is much higher at AWS. So you can be rest assured of that security aspect. Then your availability, durability. AWS promises you 99.999 all the way up to 11.9% of durability of data. So that's a huge number. Right? That's a huge guarantee. 99.99 up to 11.9 of durability. Right? So you can always be rest assured that your data is available under any circumstances. The next application that we have is AWS Glue. As the name suggests, Glue is basically combining the definition of your data with data. That means indexing your data. So that your data discovery becomes very easy. So Glue is a fully managed service again, but provides a catalog to make data in the data lake server that you can do this. So there's a huge data island. So they require some kind of tool which will allow to discover data in that data very easily. It has the ability to extract, transform, and load into data analysis. So you can use the DL as well. Also, the inbuilt data catalog is like persistent metadata, store all the data assets. It also provides you an index in it. So making all of that data searchable and available in a single view. So Glue's main purpose is to able to make the data discoverable easy. Right? When you're storing it, it should be something which is easily discoverable. That's what a tool is for in the data storage aspect of data processing. But the data injected to have stored, then comes the processing of that data. In this category, we have Amazon EMR and Redshift, these two applications. So Amazon EMR is your classic values. Okay? When you say elastic, means it is not able to scale. When you have less capacity, you have capacity. When you have more capacity, you won't have more capacity. You have more capacity. It is also very flexible payment plans. Right? Now, EMR is your Amazon's managed Hadoop cluster, basically. Right? Now, you can imagine an in-premise servers. Now, those of you who know Hadoop is basically a cluster of servers on which the data is stored and they also process on those pieces of machine pattern. And that's how, following the development policy, Hadoop is able to process all the data. When you have an in-premise, you'll have a center. In that data center, you have different servers, and you will have Hadoop server. So 24/7, that cluster is on. Right? The cooling, the capacity, everything needs to be maintained for that cluster. So 24/7. Now, when you do the same structure to cloud, okay, let's say you database is on cloud, and it's not bare metal cluster in your data center. You have what's your servers, and running up cluster on top of that. Here, what is the drawback? You are getting that you have to buy those servers, you just pay rent. It's like buying a flat at the entrance. You just pay rent for those servers. It becomes very costly. But in this also, your data is 24/7. So you are paying for those machines 24/7. You have 1,000 machine cluster, you're paying for 1,000 machines on your list 24/7. Plus you have to maintain the software versions to do operating system, all those things yourself. What if I tell you that you can delegate or you can outsource all these responsibilities to AWS, to a managed service, right? And that managed service is Amazon EMR, not only it is managed, not everything, like your software and everything is taken care of. Only data is your responsibility. But there's one more advantage of using EMR, and that is your cluster is not on and running 24/7. How is it possible? So EMR uses a file system called EFS that allows it to read the data and processing from SD buckets. So whatever data you can put in the SD bucket, we just seen on the previous slide, you can put in the SD bucket. And what you're processing, you do your high jobs, your jobs, reduce to all those processes you can in the SD bucket. Right? Let's say out 24 hours in a day. So on the day, you're collecting your data and everything and dumping it in the SD bucket. So the S3 bucket is on. You're paying for storage. Maybe a couple of hours from 12 o'clock to 5 o'clock in the morning, you are doing processing of the data. 5 hours. Right? So your actual cluster needs to be on for only 5 hours instead of 24 hours. So through EMR, actually you can make your cost cut from 24/7 to 5/7 because you leave the data and then you start your EMR cluster giving 12 to 5. It will process the data, it will generate the output. And against output again back to 3 bucket. And then 5 your EMR solution will pay only 4 times. This way, that's a EMR based management cluster, management cluster. So the EMR has that much. Let's now have a look at what all EMR can do. For a big data using Spark and Hadoop. So EMR is perfectly Hadoop cluster. You can not only have mapped using all your components, Spark components can be done through EMR. Furthermore, EMR supports 19 different open source projects. So all of your different tools that you have in the ecosystem, all those can be used through EMR, only for the cost. And upgrading those, making sure that you have an upgraded or these tools is Amazon's responsibility. It also comes with managing notebooks for data engineering, data science development, collaboration, machine learning development, all those things are available on EMR. The next tool in this category is Amazon Redshift. Amazon Redshift provides the ability to run complex analytic queries against petabytes of software data. So Redshift is your scale database available in AWS. It's a very strong database. If you have a Teradata and those kind of technologies, are very expensive. But in AWS, Redshift is the answer to that. It's those companies. And it is very integrated with Elastic like S3 and those kind of things. So it is very integrated with S3. You don't have to store your data in Redshift. You can store it in S3. And Redshift has something called Redshift Spectrum that runs SQL queries directly against gigabytes of data present, whether it's structured in S3 without the need for unnecessary data movements. So all the time everything is saved. Right? So these are technology tools that you have available in your data processing and final aspect of business is data visualization. This is where we also read to the customer after doing all those different stages in data processing. Now data output is ready to be presented to the client. And for that, we require visualizations. Now, secondly, QuickSight is a tool that is managed by AWS for your business. Now, what does QuickSight do? For dashboards and visualizations, Amazon QuickSight provides you fast cloud-powered business analytical service. So you must have worked with Tableau dashboards, Power BI dashboards. So QuickSight is Amazon based. Now the advantage of using QuickSight is because you have all of the native tools that are available in AWS cloud, it makes your big data processing very easy. So there are many other tools are also coming up because big data world is a very dynamic world. Every couple of months